Hey everybody, today we're going to do something kind of really different. We're going to take a look at this polar graph. If you've never seen one, there it is. Hello. So we've got basically the unit circle, and I know this is kind of blurry, but the next one is a little bit better to read. And then you have these concentric circles, and usually the units are counting by 1. So not only do we have to spin around, we also have to count out. So this is kind of two directions. So the polar coordinates are in the form r theta, but honestly, it's probably easier if you graph it theta first, then try to graph r. So r represents the number of rings that you're going out. So if you're going out like 5 rings, then you count out 5. But you stay on the line that is the line for the angle. Negative angles spin down, just like they always have. A negative r, let's say you're here, the negative r would shoot back through the pole and go out the other side. So it gets a little weird, but it's not too bad. So let's try some. It's probably easier just to have some numbers. Well, a graph that you can read especially, this would be nice. So 360. So what I would do is I would go to the 60-degree line right here. And from the 0, 0 on this line, you're going to count out 3 spaces. So we count out 3 rings. 1, 2, 3. And this is point A. Negative 1.5, 30. Oh, our first negative r. So go up to 30. So we're on this line right here. But it's a negative r. So we're going to shoot away from the 30, which the hardest part is following the line. And we're going to go 1.5 the other way. So between 1 and 2. I know I have all this green here. So that point right there will be point B. Another negative angle. So go to the 135 line, but instead of staying on this 135 line, we're going to shoot through the pole and come out the other side on the 315 line. But we're only going to go 2 rings the other way. So that is point C. 4, 0, we're on the 0-degree line, out 4. And 5, negative 240. So I would do the negative 240 first. All right, so negative 180, and then 60 more. We end up on this 120 line. So that's the line we're on. And now we have to count out 5 rings. So it's super helpful if you can kind of draw on your graph a little bit so you can kind of keep track of where you are. Now, just like when we do the unit circle, every point has 4 names. That's a lot. So we could have plus or minus r. We could also have plus or minus theta. So we are going to have 2 that have a positive r, 2 that have a positive theta, and 2 that have a negative r, and 2 that have a negative theta. Now that sounds like a lot, which is why I paused, but I'll show you the combination. So if we're going to have 2 that have a positive r. So we know we're going to have 2 that have a positive 2 as your r. We're going to have 2 that have a negative 2 as your r, but we already have one of them right there. So there's only 3 more points for this. I'm going to put this point on the graph, although this graph is hard to read. Sorry. 230. These are basically counting by 15 degrees. This grid is obviously much better. So this is your 30-degree line right here. So it's that second line. And so we're going to go negative 2, which means we're going to shoot back through this side. So negative 230 is over here, if that helps you. So this is our goal. Blue is the goal. Or sorry, negative 230. So we can get there very, very directly, right? We can just go right to it. And so that's on the that's on the 210 degree, right? Because this is 180 and this is 30 more because it's impossible to read. So that's at 210. So we could just go 210 and go out 2. So we could put 210 here. Another way we could get there, not have to go through the pole, is to go backwards or spin down. So this will be our negative angle. So here we go with a negative angle. The negative angles aren't hard because you're used to those. It's the negative r's that are a little bit hard. So we're going to be, again, 30 degrees away from 180. So this is negative 150. Now the other way we can get, we're going to have a negative theta here because we only have one with a negative theta. So our last one is a negative theta. That kind of helps you figure out what you got to do. So now we're going to spin the wrong way, spin down. We're going to land on the blue line so that we can shoot and go backwards. So we need to know what this almost all the way around is. Well, if that's 30, then 330 is almost all the way around. So the negative 330. I don't know if you can tell, but I really like to write on my graph. And so if you have a graph that you can write on, you may find it to be a little easier. Now this connects very well to the vectors. You may look at and see that this formula is a little bit familiar. If we resolved it in the vector into its components, we had the magnitude times the cosine, and then we had the magnitude, times the sine, and that's basically what we have here. So x is your radius times your cosine, and y is your radius times your sine. So we got a little unit circle memory jog. Never really goes away. So for x, we're going to have 20 times the cosine of 150. And for y, we're going to have 20 times the sine of 150. And since 150 is on the unit circle, you can't have a decimal. You can use your calculator, though, and you'll see that this is that negative 0.866 number. So if you know that is negative 3 over 2, then radical 3 over 2, then you know it's much easier. And so we get the point negative 10 radical 3. And the y value is 20 times positive 1/2. So that's obviously just a 10. And these are points. So if this is the polar, then this is the rectangular. So rectangular is just x and y. No angles, left, right, up, down. So just plain old numbers. So here we have the x is going to be the 10 times the cosine of negative 30. And y is 10 times the sine of negative 30. And again, feel free to use your calculator. So we're going to have 10. This is radical 3 over 2 again because it's that 0.866 number. So this is going to be 5 radical 3. And then, which should make sense, right? If I'm thinking about going out 10 and down 30, my x value is positive. Seems like my y value should be negative. And so I'm going to have 10 times negative 1/2. And there it is, negative 5. Now there's actually a key on your calculator for this, which seems dumb because it's pretty easy already to type in the calculator. If it's a non-unit circle value, then all we're going to have to do is exactly like you think, 7 cosine of 124, 7 sine of 124. You can put it in your calculator very, very easily that way. Or you can do this, second angle, and then go down to number 7. The problem with this is there's one key for x, and then you have to repeat yourself and do it again for y. Also, your calculator is very picky about the punctuation. So I even have in here that you got to make sure you use a comma. So when it shows up on the screen, and it will show up the way it says, so P, and then we have the R, the rectangular x coordinate, just gives you the x coordinate. You have to do parentheses 7, comma 124. Now you don't have to hit degrees because your mode's already in degrees, and the calculator knows, oh, first angle's R, second angle's theta. But we're going to go to the nearest tenth, and we get negative 3.9. Or, if you don't want to mess with that, just type in 7 cosine 124. So we have to do it again. Second angle, and then go down to 8. Parentheses 7, comma 124, we get 5.8. Honestly, this direction, whatever we're doing here, we're doing polar to rectangular. It's so much easier to put the multiplication in the calculator. So now we're going to do, don't know what that is. Don't know what that is. Okay. Now we're going to do 20 cosine of negative 50, and then 20 sine of negative 50, which is probably a much easier way to put in the calculator. So we get 12.9 and then negative 15.3. But you can do it any way you want to, as long as you have no decimals for your unit circle value. And if it's not on the unit circle value, you decide, calculator or just use the sine and cosine keys.